Now, as a leading video platform and a founding member of the Alliance for Open Media, it was only right that Netflix start rolling out AV1 content. But as a platform that had extensive UI needs, it was also important for them to start to explore or maybe even use the Avif format. Now, earlier this year, they wrote an extensive blog post detailing some of their experimentation with the Avif format and possible usage. Now, here to provide a summary or even an update to that blog post is one of the authors. Here to talk about that is Aditya Mavlankar of Netflix Engineering. Enjoy.
Cool. Thank you, Andre, for the introduction. Hello, everyone. My name is Aditya Mavlankar. I work for Netflix, and I'm here to talk about AVIF, also called as AVIF, for next generation image coding. Images are central to the Netflix UI. The Netflix user interface shows these images. It serves up recommendations, allows the user to browse the catalog, and these images represent the titles available on the service. And the UI is shown on several platforms, smart TVs, streaming devices connected to big displays, um, phones, tablets, and also web browsers. Oops. Okay, so here's a little view of the kids profile. This is a view of iOS. So it's rich in images. And where do these images come from? These images are actually high quality assets. We have graphics artists create them. So typically there is a base image, and then it's a heavily localized product, which means we have text from various languages overlaid on top of images. We have gradients. We have other kinds of graphics like the Netflix symbol, for example, or even title specific symbols that are put on top of the base image. In some images, we might see intricate textured backgrounds. It depends on what the artist is going for. Um, but most images have hard edges with chroma differences. For example, the bright red in the Netflix logo, that can cause a lot of color contrast with neighboring pixels and lead to these kind of hard edges. And when such hard edges are present, the color subsampling is very important. For example, if YUV420 is used, we can see color bleeding and all sorts of color artifacting. And some codecs don't unfortunately have 444. So Pascal, if you're listening and still taking feature requests, if WebP version 2 has 444 support, that would be awesome. Anyway, the point of this slide is that the characteristics of these images can deviate a lot from natural images. And by natural, I mean the images you tend to click with your cameras. Once an image is ingested in the pipeline, we create various derivatives, what we call suitably compressed image assets that are destined for different devices. And for this, we employ various encoding recipes, and we are faced with various choices, like choosing the right color subsampling, the right codec, the encoding parameters, and the encoding resolution. So AVIF, we're hoping that it could serve our image needs. So what is AVIF? It is a container like Heaf, but it allows carrying AV1 intra-coded images. And AV1 intra is more efficient than HEVC intra. And how do we know this? Because we've done these experiments, and more about that in just a bit. But like I said, AVIF has a lot of appealing features, and it could serve as a one-stop shop for all our image needs. For example, it supports an alpha channel that can be even losslessly encoded if you wish. It supports overall lossless encoding, It supports multiple color subsampling formats, including 444. It supports animations, which could serve as a replacement for animated GIFs. Avif can carry depth maps, EXIF metadata, and also color gamut and HDR metadata. HDR metadata like the transfer function and the color primaries and so on. And support is expected on major web browsers and mobile and consumer devices. In fact, it's already supported on Google Chrome, and it's available behind a flag in Firefox. So like I said, we've done experiments, and what we've created is actually a compression efficiency comparison framework that we've open sourced. And the framework allows you to easily plug in new codecs or encoder implementations or settings. And you can point the framework to a folder of source images, and it will go ahead and compress those images with various target qualities. And then you can compare the compression efficiency. And it employs several image quality metrics. So I think we report the comparison in terms of 7 or 8 different metrics. This is it's available on GitHub, and the link can be seen at the bottom of the slide. And we've used this framework to get comprehensive results on multiple public data sets as well as Netflix images. And these results were published in detail in the blog, which also Henri mentioned in the introduction. I want to report I want to report results for a couple of image types, or canvas types, if you will. One is the billboard images, which are sort of high resolution. And then also, sorry, how do I go back? Yeah. Billboard images and also box shot images, which are lower in resolution than the billboard images, and they kind of serve a different purpose. So anyway, here are the results for the billboard images. And I've chosen just two metrics, SSIM and PSNR. But like I said, the framework computes 7 or 8 different metrics. And we've reported results with more metrics in the tech blog. So for the billboard images, we can see that Avif is the top performer. The top performer is highlighted, by the way, as seen from the lens of these metrics. And we are showing results for both 420 and 444 subsampling. And the anchor for the comparison here is JPEG, the reference software. So if you see a number here like 74, it means on average, the file size is 74% less with this codec compared to the anchor, which is JPEG. And if you employ a different anchor for the comparisons, these absolute numbers might change, but the relative rankings don't change. So here are results for box shot images. And again, we see that Avif is the top performer, as seen from the lens of these two metrics. But then if you look at the blog, that's true even if you look at it through the other metrics as well. One interesting thing to note here is that the absolute, file size reduction, if you compare it to large images, we have larger gains, larger percentage gains. And with box shot images, we still have 50 to 60% file size reduction compared to JPEG. So libavif is an open source library developed by the Alliance for Open Media that allows you to encode and decode Avif images. And the goal is to ease integration in software by the image community. And such integration has already happened. For example, Google Chrome There is an app called Darktable. It's a photography workflow app. GIMP, popular and open image editing software. Then there is a module called GDK PixBuff, which is responsible for reading and writing images on most GNOME apps, etc. And the libavif build builds these encoders called, the encoder binary called avif-enc and a decoder binary called avif-dec. And here's a sample command for encoding uh, uh, an avif, which is a simple 8-bit sRGB. And the Avif encoder allows you to specify various parameters. For example, the min and max QP, the speed, the codec, like the underlying encoder. You could build in AOM or Ravi, for example. It allows you to choose the color space, transfer function, and lots of other parameters. And by the way, a special shout out to Joe Drago, who's another Netflixer. He's the primary contributor to libavif. So I mentioned the speed parameter a bit. So speed is actually a number from 0 to 10. And it's interesting to look at the effect of speed on the compression efficiency. Because speed 0 is slow, but it has the highest encoder effort. Uh, so if we look at the code, we see that speed 8 is where the mode switches to real time. Um, and we've done experiments again within the same compression comparison platform. And what we've seen is with speeds 1, 2, 3, 4, we can reduce encoding time significantly while sacrificing less than 4% compression efficiency. But if we employ something like speed 8, we see almost a 20% sacrifice. So essentially, we are giving up almost 1/3 of the gains from JPEG. So our recommendation would be to avoid speeds greater than 4. We've done some field trials of Avif at Netflix. Most notably, we've successfully served HDR images in Avif. The test focused on game consoles connected to HDR displays, because game consoles is where it's easier to have end-to-end control. And it's easier to test more bleeding edge things with shaders and such. They're pretty powerful as well. But we're also exploring ways to enable HDR graphics on smart TVs. One thing to note here is that Avif carrying AV1 intra limits the bit depth to 12. But anyway, it looks like 10 is a sweet spot where we can still convey that stunningness of HDR. And this also ties in well with the 10-bit decoding optimizations in David, which are ongoing. And then we are also testing Avif for the standard dynamic range image assets. We have a test running at the moment, which is focused on game consoles and few other streaming devices. And we're likely to test on Android soon. So I'm gonna make a plug for libavif. It's a great time to contribute to libavif as Avif sees more and more integration in products. And thank you.